So when it comes down to making a decision about a null hypothesis, your null hypothesis could be true or it could be false. You don't know what the case is. You're going to collect data and make your best guess. Now, if the null hypothesis is true and you don't reject it, that's a correct decision. There's another correct decision as well. And where's that other correct decision? Which box here?
False and decide to reject.
Yeah, it's false and we reject. So it's another correct decision. Okay, cool. Now, that means these other two are mistakes. They're errors. And this one is a type 1 error. That is, H naught is true, but you reject H naught. What else is possible over here? Well, H naught could be false, but we don't reject it. Now, they were really creative and colorful when they named this one. Can anyone guess what this one was called?
Type 2.
A type 2 error, yeah. So they went way out of limb and creativity-wise. That's your type 2 error. So, kind of in words, a type 1 error is rejecting H naught when it's true. Rejecting H naught when H naught is true. That's your type 1 error. Your type 2 error is failing to reject H naught when it's false. Failing to reject H naught when it is false. So those are the two things that can happen. Now our job is going to be to try and decide, what these are in words that relate to our problems. So let me give you some examples, starting with this one. So some paper here. So we'll start with, let's see, what example should we use this as? Sample D, maybe? So our original claim is this. 10% of people write with their left hand. 10% of people write with their left hand. Now there was an interesting thing that was true of, I don't know what it was for Donald Trump, but before Donald Trump, 5 out of the 6 presidents up to Obama wrote with their left hand, which is really unusual considering that only 10% of people write with their left hand. So it must say something about the office of the presidency. And again, I don't know if Trump wrote with his left or his right, but if that's the claim, let's start with the null and alternative hypothesis. What's this look like using symbols?
Less than or equal to 10%.
Is it a less than or equal to?
Oh no, it's just equal.
It's equal to. So it'd be P, because remember you have to write with a population parameter, P equals 0.10. Where does that go in terms of our null hypothesis? HO. P equals 0.10. What's that mean as far as our alternative hypothesis is concerned?
It is not equal.
Not equal to 0.10. So let's figure out what a type 1 error is going to look like. A type 1 error basically says that this is true, but we rejected it. Now, when you write these on the exam, I'm going to ask that you write it in words, not in symbols. I don't want to see a mu, a sigma, or a p here. I don't want you to give me a definition. I just want you to write it in words. So an example would be, it is true that 10% of people write with their left hands, but the data reject that claim. And that's it. There's nothing about null and alternative hypothesis. There's nothing about parameters, at least directly. That's it. It's nice and clean. It's written in words that relate to the problem. Okay, good. Let's try our type 2 error. Now in a type 2 error, what's the truth about H naught? Is it true or false? And if you're making a type 2 error, is H naught true or false? I've got a couple of people that says false. It's false. But if you're making an error, even though it's false, you fail to reject it. So in words, you could do this. The claim that 10% of people write with their left hand is false. False. But the data fail to reject that claim. Okay, nice, nice. Now, if you're looking at this and struggling and go, oh man, I'm really not sure what to do about these things in general, let me reduce it down to kind of like almost a formula for you. For your type 1 error, what you can say is it is true, and then you want to is true that, and then you want to state H naught in words. So whatever the word description is for the null hypothesis, state that in words, and then write, but the data reject that claim. What about type 2? In our type 2 error, the alternative hypothesis was what we believe to be true, and it's H naught, which is false. So the claim that H naught is true, so you want to say this H naught in words, that claim is false. So whatever H naught is, that claim is false, but the data fail to reject that claim. Nice. So those are kind of like some templates. There's a lot of variety that I would accept here.
So why do we say fail to reject and reject instead of just reject and accept?
Because accept has the connotation of saying that we've proved it true or that it is true. And the problem with that is that in doing a hypothesis test, you're starting out by assuming that's true. So I guess it's a hesitancy to say we're proving something is true when we assumed it's true. And that's almost what it feels like when you're saying accept. You know, at some point when I was learning this stuff, we would say accept and reject. But the fashion nowadays is more to just reject and fail to reject. So I'm going to stick with what it is currently, and that is fail to reject. I think that's, you know, what I learned, you know, eons ago aside, I think that's a better way to say it, because you are starting out by assuming that's true. So we don't want to say that we proved it true in any way. We just say we failed to disprove it. All right.
The bottom, I think, of that last point, it's what the data
Sure.
fails to reject.
Yes. Mm-hmm. Yep. So let's try another one. So call this example E. So our claim is going to be this. The mean body temperature is at most 97.3 degrees Fahrenheit. Now let me help you out with the original claim, because the first job that you're going to have to do is put that original claim into words. One of the places that you're going to be graded on is what symbol do you use here? Excellent. Mu. And then I know it's 97.3. But the other part is, well, which symbol? You're going to have a choice of like 5. 1, 2, 3, 4, 5. Which of those symbols goes with at most?
Less than or equal to.
Less than or equal to. So that one goes with at most. This one is at least. Of course, that's just equal to, and then greater than or less than. I think those are pretty obvious, but the at most and at least, those are the ones that give people trouble the most frequently. So set up your null and alternative hypothesis, HO and HA, and then work on a type 1 and a type 2 error. Yeah, yeah. So in chapters 8 and chapter 9, it's always going to be population parameters, mu, p, and sigma. Absolutely, yeah. So if you put a p hat or an x bar or an s, you'd lose a point or two. Because as you said, they're always testing about population parameters. So turn to a neighbor and try yours out on your neighbor. See if you guys agree.
Do you write type 1 and type 2 every time?
Or just.
Well, it's a question that I could ask on the exam is to discuss a type 1 and type 2 error in words. So
This is just practice, but like.
this is just practice for that kind of thing. Yeah. Mhm.
What he wrote was the original.
Because he's gonna
Cause
say.
that's because at most, or everything has 4 equals to that, you know, so it's like honestly close. Yeah, so you just do it, because you can use all these for each other. And then for each page. Yeah, that's one I use. And then type 1 is just reject when it's true. True. So the number type 1 is just when you say it's HO's not true, you reject HO even though it's right. Reject HO even though it's right. And it's true. Say HO is true. All you gotta remember is that basically saying no when it's actually it's actually the language of type 2.
So good discussion there. Like seeing that.
Yeah,
Ladies, you agree?
M is less than or
Gentlemen, you guys agree? All right, all right.
I agree, but the data reject that claim.
I honestly don't even know. I have to watch the video. But
I just followed it, whatever that template was, I guess, but.
That's like all the wording.
I know.
Failed to reject.
How do I
U
know
is
it's not
less
true?
than equal to 97.3 when there's sufficient evidence that is less than equal to. That's what you could say. But you say it's right when it's wrong, so say it's right. Yeah. Yep. You gotta remember.
All right, so anyone want to give theirs a shot? Let me see, this might be one in the chat here. Good job, Philo. All right. So, is anyone at home? This is one of my Zoomers. Want to give this a shot? What's your type 1 error look like in Word? Oh, by the way, if this is less than or equal to, that's going to go in the null hypothesis. What has to go in the alternative?
Greater than?
Greater than. So greater than 97.3. All right. So how about our type 1 error? Some of my homebodies? No takers. Anyone in class? Yeah.
It is true that 97.3 degrees Fahrenheit is the mean body temperature of most people with the data rejected that claim.
All right, it's true that the 97.3 degrees Fahrenheit is the true mean body temperature. True mean body temp. But the data reject that claim. Perfect. Now, there's a couple things that I'll be looking for when I grade yours. There's a lot of variety here. Does anyone else want to try theirs? Nate?
It is true that the true mean body temp is at most 97.3 degrees Fahrenheit, but the data rejected the claim.
Sure. So to repeat that, it is true that the true mean body temperature is 97.3 degrees Fahrenheit, but the data rejected that claim. So yeah, nothing wrong with that one at all. What I'm looking for is you to tell me what's true, or you know what's the situation with H naught. So in the case of a type 1 error, H naught is true, and that's exactly what you start out with. It's true that 97.3 is your true mean body temperature. Okay, that's great. And then I want to know what your decision is. So there's two parts of this. What's the status of H naught? What's your decision? H naught is true, but we decided otherwise. With the type 2 error, it's flipped around. H naught is false, but we failed to reject it. How would that look in words? I want to give that one a shot. Victoria?
The claim that 97.3 degrees Fahrenheit is false, that the mean, that, or something along the lines of the mean body temperature.
All right, so it's true that the mean body temperature, let's see, wait. That's actually, want to try that one again?
The claim that 97.3 degrees Fahrenheit is not the mean body, because in.
All right, yeah, the claim that the mean body temperature is 97.3 degrees is false. So that's telling me what's going on with H naught.
So it doesn't even matter what the sentence tells you in the beginning, you can either, you're just gonna say whether it's, you can just say it's false and it's true.
Yeah, so in type 1, H naught is true, in type 2, H naught is false. So that's really what you're saying here in one way or another with your first sentence.
Reiterating H naught, okay.
Yeah, so this claim is false, and then finish it up. What was our decision?
But the data supports that claim.
Does the data support that claim?
Fails to reject
Or fails to
it.
reject.
Fails to reject it, yeah. But the data fails to reject that claim. Nice, nice. All right. You want to try one more?
Yes.
Okay, I think it's not a bad idea. So our claim standard deviation of daily temperature in Oakland County is less than 2.3 degrees Fahrenheit. So that's your original claim. You've got to decide what HO and HA are, and then a type 1 and a type 2 error. What would those look like in words? Please don't use any symbols in this.
That says 2.3?
2.3, yes. I mean, I really have no idea what the actual temperature is. I just chose that one just to do an example. let's make sure we're on the right page with HO and HA, because if you don't have these right, then your type 1 and type 2 errors are going to be off. So what symbol should I be using when talking about the original claim? All right, so it should be sigma is less than 2.3. Is that part of the null or alternative hypothesis?
Alternative.
Alternative. So it's going to be sigma is less than 2.3. Esther, what's that put in the null hypothesis?
That's gonna make the null hypothesis, it's gonna be greater than or equal to.
Nice. Now, on my stat lab, you'll just enter in sigma equals 2.3. That's okay. You can do either one of these on the exam. But now you got to work with your type 1 and your type 2 error. So I'll give you a few more seconds to work on that. Somebody type it in from home. Somebody tell me what that claim is in words. It's your chance to get yours tested without really losing any points.
The type 1 error is always the null.
The type 1 and type 2 error always go back to the null. In one case, the type 1, or in one case, the null hypothesis is true. The other case, the null hypothesis is false. But your decision when you make an error always has to be the wrong choice. So if H naught is true, the type 1 error says you're going to reject that. If H naught is false, type 2 error says you're going to embrace it and say, oh, yeah, we're going to accept this, or fail to reject it, I should say. Whereas type 1 error says, all right, this is true, but we failed to, this is true, but we rejected it.
So what's even the point behind double crossing yourself?
What do you mean double crossing myself?
I mean, why are you gonna put the wrong answer when you know intentionally it's the wrong answer?
Well, see, that's the thing about hypothesis testing. We don't know.
Oh.
We don't know what's true. Just like in a jury trial. I mean, somebody could be convicted, but were they really guilty? Well, there was a lot of evidence that way, yeah. But do you really know? No. There's been lots of cases that have been overturned because they found some more evidence or this, that, and the other. And the same is true with hypothesis. We don't know. We're making our best guess. And the point of this, and it's a great question, the point of this is to understand what are the consequences of these errors. Because, you know, if the consequence of a type 1 error is really severe, you want to minimize that consequence. So a couple things here while I'm letting you finish this up. The probability of a type 1 error is alpha. So you can control that. This is the same alpha that we use when we're talking about z sub alpha over 2 or your chi-square sub L, chi-square sub R. That's that same z sub alpha. The probability of a type 2 error, well, first comes alpha, then comes beta. So, and one more little note here for you. The power of a test. So the power of a hypothesis test is 1 minus beta. That's a question on one of your homework problems. So there's the answer.
Okay.
All right, so I hope that folks of you were chatting back there got this last little bit. The power of a hypothesis test is 1 minus beta. Probability of your type 1 error is alpha. Probability of your type 2 error is beta. Let's look at type 1 error and type 2 error in words. Does anyone want to give this a shot? Someone I haven't heard from. Adel? No, I appreciate that. We'll spread the wealth. So they claim that the standard deviation of temperature is at least 2.3 degrees is true, but the data reject that claim.
Why'd you use at least?
Because greater than or equal to is also synonymous with at least.
So it wouldn't be less than?
No, because less than puts you in the alternative hypothesis, and you either reject or fail to reject the null hypothesis. So your decision is always going to go back to the null hypothesis. So the claim that the standard deviation of temperature is at least 2.3 degrees is true, but the data reject that claim. There could be other varieties. Does anyone want to give theirs a shot? There's a few in the chat here. Let me take a look at those. It is true that the standard deviation of temperature in Oakland County is less than, let me ad lib this a little bit, is less than or equal to 2.3 degrees, but the data fail to reject that claim. That's not exactly right. Because the data do reject that claim. What you've described there is like a type 2 error, is closer to what you've described. So what you've got to do is state that this is true. You want to state that true in words, and that you rejected that claim. Let me look at another one, and then there was a couple volunteers that I had up here. Type 1 error is, it is true that the standard deviation of daily temperatures in Oakland County is less than or equal to 2.3 degrees, but the data rejects that claim. Perfect. And then I got a couple for type 2 errors. Let me hear from type 1 error. Ethan?
Can you flip the order where you say the data rejects the claim that the temperature is at least 2.3 degrees, even though it is actually true?
Yes, nothing wrong with it at all. So the way I did it was kind of like a template, but the two things I'll be looking for are that you rejected the claim of H naught and that that claim was true.
Okay.
So if you want to say it like you did, the data reject this claim even though it's true, perfect. Nothing wrong with that at all. In fact, it flows pretty nice, to be honest. How about type 2 error?
It is not true that the true standard deviation of daily temperature in Oakland County is at least 2.3 degrees Fahrenheit, but the data failed to reject that claim.
Okay, it is not true that the true standard deviation of temperature in Oakland County is at least 2.3 degrees, but the data failed to reject that claim. Okay, good. So what you're stating is that this is false, but the data didn't reject it, even though it should have. So, perfect. Does anyone else want to give that one a shot? Yes.
It is true that the standard deviation of daily temperature in Oakland County is at least 2.3 degrees Fahrenheit, but the data rejects that claim.
That's type 1, right?
Type 1. Oh, are we doing type 2 now?
Yeah, we're doing type 2. You want to try type 2?
Yeah, the claim that's the standard deviation of a daily temperature in Oakland County is less than 2.3 degrees Fahrenheit, but the data fails to reject that claim.
You got to be careful because you said something about this claim. You should really be referencing H naught here, because this is false, and the data fail to reject that claim. You ventured off into HA. I'd probably suggest you stay away from HA, but I appreciate the effort, and I'm sure you've helped some people here. Anyone else want to give type 2 an error? Let's see, there's one here. Let's see. The claim that the standard deviation of daily temperature in Oakland County is less than 2.3 degrees is false, but the data fail to reject that claim. Again, you're making a statement about the alternative, and you really should be talking about the null hypothesis when you're discussing your type 1 and type 2 errors. I'd stay away from the alternative hypothesis. Here's another one. So it is false that the true standard deviation of daily temperature is less than 2.3 degrees. That's a good start because you're saying this is false. Actually, you know what? You've got your inequality backwards. What's false is that the true standard deviation is at least 2.3 degrees, but the data fail to reject that claim. So you got to be careful about that. Let me state this in words. it is false that the true standard deviation of temperature is at least 2.3 degrees. So you're saying this is false. But because we're making an error, we fail to reject that claim. But the data failed to reject that claim. No, that'd be okay. Yeah. So if you wrote equal to there, that'd be fine. Because that's another way to write the null hypothesis. So if you said it is false that the true standard deviation of temperature is 2.3, but the data failed to reject that claim, that's fine as well. Okay, comments or questions on that second part here? Justin?
So are we gonna be tested on probability? Because I'm a little lost on that.
No, there's really not much that you're gonna do with the probability at all. I'm just trying to bring this back full circle and mentioning that the probability of a type 1 error is alpha. So you can control alpha ahead of time. You could say, oh, I want alpha to be 0.05 or alpha to be 0.01. I mean, obviously you'd like alpha to be 0, but if you make alpha equal 0, then you're never gonna reject anything. So you can't do that. This other part here, I mentioned just because it's one of your homework problems. So I'm just giving you the answer saying, here it is, have an easy one. This is not something I'm going to test you on. Beta is not really a part of this course. Alpha, we've already seen alpha. It's the same alpha that we use for confidence intervals. It's the same alpha that we're going to use in our hypothesis testing. So that's why I mention it here. It's not something you're really going to get tested on directly. All right, so good question there. All right, if there's nothing else, let me